Hello everyone, welcome to my YouTube channel Easy Coding with Ankit. Today's topic is lower and upper bound. Let's get started. We know whenever we want to find any element in array, there are two different algorithms, linear search and binary search. Linear search is used in case of unsorted array and binary search is used in case of sorted array. This lower bound and upper bound is just an extension of binary search. Here also we will search an element but we need to find the lower bound of that element. And what is lower bound? Lower bound is the let's consider we have an array and we need to find a element that we can say 3. So inside the array 3 is available multiple times, so we need to find the first uh, element available in the array, that we will call as a lower bound. Time complexity of this algorithm is also same, log of n, as same as binary search, and space complexity will be big of constant. Let's take one example. Here you can see I have created an array. It contains 1, 2, 3 two times, 4, 5, 8 and 9. Now we wanted to search 3, then we can say the lower bound of 3 is located at second index 0, 1 and second index. If let's say you wanted to find 9, then it will, as it is only one time, then same index will be returned. We don't have to worry about this lower bound, and upper bound will be applicable if you have multiple times same number is available inside the array. Same way, upper bound also. Upper bound will be considered as the last element in the array. Time complexity of this is also same, and space complexity is also constant. If you see the example, second index we have written as a lower bound, third index we will return as a upper bound. We just need to search this element and return the index. And for that, what we will do, first we will write the binary search algorithm and then make some few changes on that for both lower and upper bound. Let's write the algorithm for that. I have created the same array here. For lower bound, I will create a separate function, public static int lower bound. We will take two arguments, array comma int key. We need to find this key in this array and we need to return the lower bound of that key. So just like binary search, what we will do, we will create two pointer, int low, int high, -1, and then we will add a while loop, and here we will check low is less than or equal to high. Whenever high will become lower than low, then only this we will end from this while loop. Inside that we will try to get mid value. For that, low plus high divided by 2, and then we will compare this array of mid with key equal to array of mid. If it is equal, then we have to return mid, else that first we are writing binary search algorithm, so it will be easy to understand what changes we have to make in lower and upper bound logic. If key is less than array of mid, then we will change high to mid -1, else we will change low to mid +1, and at the last we return -1. So this is the logic of binary search. But for lower bound, what we will do, we will make few changes. We will create a new variable that we will call as answer, and there we will store -1. we know that we don't, if whenever we don't find any element, we will return minus 1, and same temporary variable we will return it. Now we need to store the index value in this answer variable. For that, what we will do, inside this if condition, first if condition, whenever the key is equal to array of mid, that time we will store answer equal to mid, and then we will change high to mid minus 1, and here we will not return anything because at the last only we are returning the same variable. So that's the modification we are doing in the binary search. Let's call this and check if it is working fine or not. Lower bound will pass key as 3. We need to get output as 2. You can see we got output as 2. Let's try with other element as well. Let's pass 9, as 9 is only one time, so it will return 7. Let's try to find a number which is not available inside the array. I will pass key as 14. Let's call this, I'm getting minus 1. So all like different scenario is working fine. For upper bound, what I will do, I will copy this algorithm, same algorithm, and just copy paste, change the name, upper bound, and here a small modification we will do. Instead of changing high to mid minus 1, we will change low to mid plus 1. That's all. That's the only change we will make, and now it will work for upper bound as well. Let's call upper bound and test how it is working. For 3, now instead of 2 it should return 3. You can get, see, I'm getting 3 instead of 2 because now we are getting upper bound of the 3 element, and 9 and for 9 we are getting 7, and 14 we are getting minus 1 because 14 is not available inside. So that's about the lower bound and upper bound logic. Thank you for watching my video.